Hi everybody, Patrick here from EngineeringShop.com, electroniclessons.com, and paintballprofs.com. Today I'm going to show you how to make a clap-on, clap-off circuit using our Arduino Protoboard, currently on Kickstarter, link below. And in the next video, I'm going to show you how to make a double clap-on, double clap-off. I'm making a continuation of the last video where we made a light detector. The circuitry is even simpler than our last video. We're just going to use the same microphone circuit we used in our last video, and we're going to implement one of our onboard LEDs. All of the code samples will be available to those who pledge to the Kickstarter, but if you're not interested in the Kickstarter, you can still follow along, and we'll still go over the code in this video, and we'll go over the connections. So again, if you watched our last video, this circuit should be very familiar to you, but just in case you haven't, I'll go over it again. We've got a 10K resistor connected to our 5-volt line, and in series with that we have an electret microphone. The positive of the microphone is connected to the 10K ohm resistor, and the negative of the microphone is connected to the ground line. We have a coupling capacitor, a 0.1 microfarad ceramic capacitor that acts to couple AC signals or audio signals detected by the electret microphone. It blocks the DC element on the left and couples across that little AC pulse that's relative to the audio signal that the microphone detects. R3 is a bleeder resistor, and the larger that bleeder resistor, the larger the signal that will be coupled across it. 47K is a good number for this project. So we're going to connect that coupled line to our A0 input on our Arduino Protoboard. That is our analog pin. Now, if you want to know more about analog pins, all of our videos are linked below. Start at video 1. So now let's connect this to our protoboard. The connections are a little bit easier than our last project. The noise detector, we've removed our LCD from the equation, as we're only going to use our microphone circuit and an LED. We're going to use LED number 1 on the left there, the lower left. In any case, to connect what you'd want to do is connect this circuit on your protoboard, and you'd want to connect the top of the 10K ohm resistor to the 5-volt line in red. Both ground connections on the microphone circuit should be connected together and to the ground rail on the bottom. Our GPIO2 in blue is connected to L1 for LED 1. So the output 2 from the Arduino controls LED 1. And lastly, we want to connect the coupled AC output from our microphone circuit to the A0 line on the upper left there in yellow. Once you've made those connections, as long as you've uploaded the software provided onto your microcontroller, your Atmega 328P PU, then we should be ready to go. Now let's talk about the code. This code is a little bit different from our noise detector project, linked below, but it's still easy to follow, and I've even added in some fun extras that'll help for you to calibrate your own microphone values if you're not using the microphone that I'm using. Let's start at the top. We're going to create an integer called analog value, and this is just a register. We're going to use this integer and we're going to store values in it. We're going to store the digital value taken from the A0 input. So when we clap, that analog signal is turned into a digital value, and we're going to place that in the analog value integer. We're going to define GPIO2 as LED. We're going to give that GPIO a name. We're going to create a Boolean function called toggle, and we're going to set it to false. Now, the Boolean function can be false or true, and this is going to help us to determine whether we should be toggling the LED on or toggling the LED off. In our void setup, we declare our LED as an output. Pin mode LED, we've named LED, which is associated with GPIO2, to an output. And here's one of the fun optional extras that you don't need to input into your code. You can if you want. Serial begin 9600 sets the Arduino to transmit and receive at 9600 baud. And this allows for you to, if you're just using your Arduino Uno, you can use the serial monitor with your computer, and what we'll be doing is we'll be printing analog our digital values after a clap is received. Get to that in a minute. Anyhow, onto the void loop. This is where it gets a little bit This is where it gets easy. I think this is quite easy. There's an if and an else statement. The if and the else statement are both very, very similar, but one toggles on, one toggles off. Now remember our toggle, our Boolean function named toggle. It is false. So at the beginning of void loop, if toggle equals false, which it is, digital write the LED low. So turn the LED off. Analog value, our integer, will equal what voltage is on analog A0, the A0 line. So this statement takes a reading on the A0 line, which is connected to the AC coupled output from our microphone circuit, and it stores that analog to digital value. It stores the digital value in analog value, which is our integer. Then the statement if analog value is more than 3, then we go into the next part. We change our Boolean function to true. It was false. Toggle is now true. Serial print to the computer. Again, you don't need to do this. You can if you want. Serial print to the serial monitor your analog value, in which case it would be more than 3. It would say 4, 5, 6, or 7. And then there would be a 200 millisecond delay, and then we would go back to the top of void loop. However, now toggle is true, so we ignore this first if statement, go directly to else. Turn the LED on. So now the LED will always be on until we get another clap. This will keep looping. It'll take another analog, another ADC reading from the A0 line, store that in analog value. If analog value is more than 3, toggle our Boolean function toggle equals false. We serial print to the computer the analog value, which is optional, another delay, and then we go back to the top of void loop. But now toggle is false again. So we're going to essentially go back and forth. Toggle on, toggle off, toggle on, toggle off. Everything is commented here. Everything will be available to you if you pledge to the Kickstarter campaign. All of this code, the actual INI file. So yeah, check out the Kickstarter below, and let's do one more quick look at the board. So there you have it. I've got a lot of extra wires going on here because I'm working with 3 different projects at once here. But you'll see the microphone in the back, and there's a couple of resistors. There's the 10K, there's the 47K. The A0 line is over here. Our GPIO2 is connected to L1, LED1, and now again, if you have this chip connected to your Arduino and you're connected to your computer, you can just open the serial monitor and it will read out those analog values. It's as simple as that. So check out the Kickstarter link below. Thanks. I hope even if I don't get your pledge, I hope that this video has been helpful to you. You can also check out the other videos linked below. Thanks again.